This property means that ordinary multiplication of scalars associates with the scalar multiplication. So let's consider this vector v with components 4 and 2. So kung makikita nyo dito, there is no effect on the vector. So same lang siya. And also with this one. Okay? But if we increase, for example, r, so our r is in blue here. So if we increase our r to say 1.5, ayan. Okay. So if you could observe, the vector v is now scaled 1.5 times. Okay, so that is just 1.5 times 1 is 1.5, right, times the vector v. So 1.5 times 4 is 6, and then 1.5 times 2 is 3. Dito naman, so 1.5 times the quantity 1 times b is still 6, 3. But kung makikita ninyo dito, alright, itong red is that is 1 times vector v. So this is just the vector v, while this 1.5 of this vector, meaning isi-scale mo itong vector na ito, this red here, you scale that 1.5 times. So 1.5, so this is 1 here, from this point up to this, the head is 1, and then plus 0.5, kalahati nito. So you have this one. That is why from here up to here, that's 1.5 of this vector na red. Let us try to increase our S also. Let's say our S is equal to 2. Okay. This case, 2 times vector V. So, ibig sabihin, you scale this 2 times. So, okay, this one is 2 times the vector V. Okay, and then you scale this one 1.5 times. So, again, 1.5 of that. Pero kung i-increase mo itong R, let us say, let us say, that is 2.25. So, this blue here, that is 2 times V, alright? So this is 2 times V here. If you scale this red 2.25 times, ibig sabihin, dalawa nito at saka 1/4. Okay? So that is just from this point up to this point. And if you could observe, while we are manipulating this side here, this one also is the same with this particular vector. That is why we have this equality here. Lastly, we have the property that 1 times or multiplication by the scalar 1 is the identity operation, because 1 times any vector is the same vector. So, for example, ito na vector, you multiply that by 1. Okay, so by definition, you multiply 1 to all components of V. So 1 times 5, then 1 times 2, 1 times 5 is 5, 1 times 2 is 2. That is just the vector V. Geometrically, the vector is the same with this vector. Ibig sabihin, it is scaled only 1 times. So, hindi siya nagmaba or umiksi. So, as is siya na same lang dito na vector. So for now, we view vectors in r squared or in r cubed as a directed line segment. We can also view vectors as a 2 by 1 matrix, or we can view this one as unordered pairs. But there are vectors that are hindi lamang siya represented as a directed line segment, hindi lamang siya ordered pair or matrices, but there are also vectors that are functions. There are also vectors that are continuous functions or vectors that are of the size m by n, hindi lamang vectors na 2 by 1. Alright? So, and naging inspiration na itong vectors in R squared or R cubed to define those particular vectors that resembles the same properties with the vectors present no, in R squared or in R cubed. And to formally define that one, we have what we call the real vector space. So we will know from here what are those other types of vectors that are not only no, na directed line segment or matrices. Okay? Pero kung mapapansin nyo, no, this is the definition of the real vector space. These are similar to the properties no, of the vectors in R squared or in R cubed. So naging inspiration yun siya to generalize or to come up with an idea of what are other vectors na hindi lamang ganon yung itsura. Okay? So, this definition says that a real vector space is just a set V of elements. In this case, we have two operations. Okay, these are two operations satisfying the following. First, if U and V are members of V, then the sum of two vectors is in V. This is called the closure property. Okay. Ibig sabihin kung i-add mo yung dalawang vector, hindi siya dapat lalabas dito sa vector V mo. Dapat nandoon lang din siya dapat kapag i-add. Alright? So we will call this property A1. Okay, sa A1, sabihin nito U plus V is equal to V plus U. So vector addition in this case is commutative. So as I said, pareha lang yan siya sa mga properties, no? So but this one is generalized form. Yan. So this is associative, existence of the zero element, and existence of the negative. In this case, this is the additive inverse. Now for B, so we are now on the multiplication part. So if U is a vector and C is any scalar, then C times a vector is in V. So again, this is closed under scalar multiplication. Hindi pwede na kapag i-multiply mo itong dalawa, lalabas siya sa V. But it should be in the set V. Alright, so this one is, we will call this one property B5. Okay, so kanina sa R squared or kanina sa R cube, parang distributive lang din ito over the two vectors. Okay? This one is also distributive over the sum of the two scalars. Again, this one is associativity ng scalars. Okay? And vector multiplication. And this one is the identity under multiplication. So 1 times the vector u is u for any u in V. The elements of V are called vectors. So tatawagan natin kung for example lahat ng ito ay nasatisfy ng set V mo, tatawagin natin ang mga elements ng V natin na vectors. Again, if one of these properties are not satisfied or if one of the properties is not satisfied, then we will not call it a vector. So, tatawagin lang natin siya na vector kapag na-satisfy niya yung mga properties na ito. There are 10 of it. Alright? So, 4 plus 1, so 5, and then plus 5 here. So, 10. Dapat kailangan masatisfy niya. The elements of set of real numbers are called scalars. So, wala nang pagbabago dito, no? So, the operation, this one is called the vector addition, and this operation is called the scalar multiplication. The vector 0 in property A3 is called the zero vector, and the vector negative u in property A4 is called the negative of u. A set V and two operations, this vector addition and vector multiplication, satisfying all the properties of the definition is called the vector space. So kung lahat-lahat ng 10 na yon ay nasatisfy, ang tawag natin doon ay vector space. So for our notation, this one is called the set together with operations plus and vector addition and scalar multiplication. We remark here that the zero vector and the negative or the additive inverse are unique. To prove that one, suppose that there are two zero vectors. Let us denote that 0, 1 and 0, 2. Then, by definition, because they are zero vectors, because 0, 2 is a zero vector, so added to 0, that is just 0. And similarly, we know that 0 sub 1 is a zero vector. Therefore, if you add that to another vector, the result is still that number. So it will not affect. Thus, we have here 0 sub 1 is equal to the 2, this one. And ito naman is equal to 0 sub 2. So transitivity lang yung ginamit natin sa equality. So we are forced say that 0 sub 1 here is equal to 0 sub 2. Ibig sabihin, kung meron ka mang dalawang vector na, the zero vector, lalabas pa rin na same lang sila. This means that this one is unique. This means that the zero vector is